Yes, we're getting video again. We haven't been getting video for a while, and we got it back. Nice, nice, nice. Okay. Welcome, welcome. Come on in. Come on in. All right. So it's 12:30, and we're going to be covering a unique topic today about functions and how they work, and something called the function call stack. So welcome everyone to another wonderful session of CSE 8A, Intro to Programming in Python. And as I said, today we're going to be covering functions and how they work. But before we do that, just wanted to show you a really quick video here. Whoa, 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 whoa. Okay.
Minister.
Oh, jeez, what's going on? Ooh. Am I on 2 times speed? No.
And got.
Whoa, whoa, whoa. What is going on? Oh, geez, okay. Alright. Okay. Oh my goodness.
Dude, it'd be like some key might be being pressed down. And that
Any keys happening here?
And when you're
Oh my goodness.
which
Okay. Alright. So, I don't think we can see the whole video right now. That's unfortunate. Some technical difficulties. But basically, this video, what we wanted to talk about with this video is the ethical dilemma of self-driving cars. And basically the ethical dilemma of the things that we create. And that's why we have to be very specific about the things that we're creating and knowing what the things we're making and why we're making those things that we're making and the actual effects of the things that we make. So think of a self-driving car, okay? A self-driving car. Who knows a little bit about self-driving cars? Kind of, sort of. Yeah, kind of, sort of. So basically, they're cars that drive themselves, right? You can have one person in it. You can have an entire car full of it, right? But basically, you're not supposed to be touching the wheel. It'll be driving all by itself, right? And let's assume we're like 100 years in the future, right? And these self-driving cars are splendid, perfect. They do work exactly how we want them to work, right? But how do we want them to work, right? We have this self-driving car, and it's in a scenario, right? It's in traffic, it's driving, and out of nowhere, the car in front of it slams its brakes, okay? It slams its brakes. When it does that, this self-driving car has to do something, okay? If we were, okay, so this self-driving car has to do something. It could do one of 3 things. Sorry, actually, one of 4 things. It could do one of 4 things. One thing that it could do is also slam its brakes, right? It's going to also try and slam its brakes. But it's realizing that no matter how hard the brakes are going to slam, it's going to hit this car, okay? That's all that's going to be happening. So one thing that it could do is slam its brakes and still hit this car. That's one option. Then it has the other option. It could slam its brakes, try to turn to the left, but turns out there's another car over here, right? So it could slam its brakes and hurt this car instead. Or it could slam its brakes, turn to the right, hit this car instead, right? Because of this, it has to make a decision. How will it make that decision? What are some things that we can consider as to where it should be going? Should it hit this car? Should it hit this car? Should it hit this car? What should it do? Yes?
Maybe like the speed at which you would hit each car.
The speed at which you would hit each car, okay. So maybe hitting this car would be, say, 70 miles an hour. This one would be 50 miles an hour. And this one would also be 50 miles an hour. Give or take, okay? So we slammed on the brakes a bit, and it did slow down. So maybe we should take the speed into consideration, all right? So maybe we can hit one of these 2 cars, right? But what happens if we're just taking speed into consideration? This has 1 person in it, this has 1 person in it, and this has 5 people in it, okay? Are we valuing these cars differently now? Maybe we are, should we? What makes these lives more valuable than these other lives? Right? I don't know. What if instead of a car it was a bike? Right? A bike which does not have any protection, right? Cars have more protection, it's got a lot of metal around it. But what if there was a bike, right? What if we were driving and we could either swerve and hit one bicycle rider or swerve and hit 5 people, but these 5 people have a metal encasing? Which one should we go to? We don't know, right? We don't know. But a self-driving car has to make that decision, right? And the difference between self-driving cars and a regular driver is one of 2 things. And it shows in the video. Unfortunately, you can't see the video right now. It's something weird's going on in my YouTube right now. But when one is driving, let's say I was driving, and I'm in this scenario, what am I going to do? I don't know. I'm going to react immediately. Split-second decision. We know that I could not have seen this coming, right? And I'm just using the information I have right there with me, and I react. It's a human reaction. Do I swerve? I don't know. Do I brake? I don't know. I don't know what I'm going to do. But it's going to be a reaction. However, with a self-driving car, this is programmed, right? There's something programmed within it. And we have to tell this system what to do beforehand so that it knows what to do, right? Because this computer's not going to be able to react. So we're going to have to tell it what to do. And that's the difference between a person that's driving and a self-driving car. Where when we have a person that's driving, that person that's driving is going to react some way. And we as a society will understand this person just reacted, right, in a split-second decision. But now with a computer, right, inside of a car, someone had to program into here some sort of decision, right? And that is where we get into some ethical situations of like, what should we be doing? Why should we be creating this? Should we even be making self-driving cars? Maybe, maybe not, right? Self-driving cars, the whole idea of it is to try to create a more safe environment, right? A more safe environment out in the streets. But now when we're taking this into consideration, these sort of questions are the things that come up, and the sort of questions that we as programmers have to think about when we're creating the systems that we create. Maybe you don't want to work in self-driving cars because all of that is very stressful. That's my decision. I do not want to work in self-driving cars because I know that someone has to make that decision. And I do not want to be a part of that, right? And on top of all that, who's at fault? Let's say this car goes and hits someone and someone unfortunately passes away. Who's at fault? Is it the person that broke really suddenly? Or the person before them? Was it the person driving this car? Who's driving the car? It's driving by itself. Is it the person that was inside this car? Is that their fault? Is it the company's fault? Right? The company's fault who created the system that did that and chose to hit this other person that ended up passing away? Is it the company itself or the programmer who actually wrote down the code to say do that? Is it their fault? It becomes very convoluted, right? And we have to think about these situations when we're creating our systems. Of course, the systems that we're creating right now is a lot of printing, functions, hello world, that kind of stuff, which is great, right? Right now it's not really affecting anyone, right, in a really strong way. But as we continue on doing our programming careers, if you decide to keep on going, these are the type of questions that you may be facing when you're creating systems, right? Where you're working, why you're working at the places that you're working, that type of stuff, okay? This is just a quick aside before we get into today's lecture, okay? I really wish this would have worked.
That bike
Unfortunately, as you can see,
is
something's crazy is going on. I don't know what it is. So I highly recommend y'all check it out in the slides, okay? With your YouTube that may be working. All right, anyways, some announcements. Our midterm is on Wednesday, all right? This Wednesday, in 2 days. And we will not be meeting here, all right? It's gonna be during lecture time, but it's not gonna be in this classroom. Do not show up here on Wednesday. Wednesday will be in the CSE basement. I think it's B260, right? So do not show up here, because if you show up here, you're gonna have to walk all the way over to the CSE labs, and you're gonna be missing all that time to be doing your exam, okay? I think we might be having like a tutor or TA that's here to point you to the right direction, right? Do not come here, go over there. But please, 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 try and get to the lab before anything happens, because the exam starts promptly at the start time at 12:30 for us. And it will end promptly at 1:50 for us, right? So that's that. We did already release some practice exam questions. All of this is all on EdSTEM, right? You should have gotten an announcement that instructor Amshad Shah gave out, right? And there you'll be seeing a bunch of different types of questions that we will be seeing in the actual midterm itself. Very similar type of questions. Some true or false questions, some multiple choice questions, some select all that apply questions, some coding problems, right? And in the practice, we gave you like 3 different coding challenges. For the actual exam, you're only going to need 1 programming challenge. But we're just giving you a lot of stuff to practice, right? And then please go back and look at your discussion material, look at your lab material. This is going to be very helpful to review for the midterm itself. Okay, any questions about the midterm? No? Yes?
The solutions for lab already viewable.
Awesome. So now if you're using your labs to go and study, thank you, Audrey, the solutions to those labs are now viewable. So you can go and check to see what were the answers to the lab questions that we were asking. Yes?
Where can I find the answers to the practice exam questions?
Answers to the practice exam questions. I don't know if we actually have released those. Also, do you remember if we're going to be releasing
I'm checking
those?
if right now they see it after they submit.
Okay. We'll get right back at you with that, okay? We're also having a staff meeting later today, so we'll try and see if we can do that, okay? But if you have any questions about what's actually in the practice exam itself, remember we also have office hours, tutor hours that are available for all of you. There's some remote hours so you could do it online, or in-person hours so you could meet us there in the basement. Sound good?
Yeah, thanks.
Awesome, great. Any other questions about the midterm? No? All right, so last class we talked about references, objects, and methods, right? And how to modify certain things, things that are references versus objects. Do we remember what references and objects are?
Oh, yeah.
Yeah? What may be a reference? What could a reference be?
Like you calling out to that object.
Yes, you're calling out to a certain object, right? And what are some examples of objects that we've seen before?
A list.
Like a list, right? A string. These sort of objects things before, right? So we have references and objects. And we can look about how we can modify a list within a function. Why can we modify a list within a function? Do we remember why we can modify a list within a function?
Is there mutable?
Because they're mutable. All right? You can go and you can actually grab these lists and mutate them, change them into something that you want to make them to be. Right? Can you do the same thing with all data types? No. What about strings? Can you go and grab a string and change it? No. What about an integer? Can you go and grab an integer and change it?
Yeah.
Can you change an integer? Let's try it out. Okay? So if we were to go over here, and we had, oh, actually let me do it in Python tutor so we can see exactly what it looks like. So we have a function called change num, right? We pass in a number, and we're going to make num equal to 7, and then, I don't know, print num. Then we can do x is equal to 10, change num with x, and then we can print x, right? We can do that. If we were to do this, we have our function, right? Python tutor, or Python reads the function and says, okay, I know there's a function. I'm not going to look into it yet, but I know that it exists. Then we have our x is 10, right? X is 10. 10 is what type of data type? Int. It's an integer, right? There's no decimal place, so it's not a float. Then we go into change num. Okay, change num, which is our function name. So we're going to try and change a number. And inside of our change num, we have this little variable called num, right? Num, and num is 10. Why is num 10 right now?
Because x equals 10.
Because x is equal to 10, right? But as you can see, this is a different sort of, this is a different object, right? And a different reference to that object, right? Actually, maybe this is not the greatest example, but let's just finish this example as we're going through it. So now we have num, and we're changing num to be 7, right? At line 2, we say num is not 7. We print the number, right? We have number 7, so we're going to print out 7. It shows right here. We're not returning anything. Then we go into print x, and we print out x, which is 10. Because 10, this x never changed, right? X never changed. But I guess a better way to show it is something like this, like a regular. Actually, I could. I mean, we have a lot to cover today, but basically, to let you know, ints, you cannot mutate them. You can't change what that number is, right? You can get your reference to point at another object, which is a different integer, but that integer itself will not change, right? So if you have a number, right, a number 27, I'm a reference and I'm pointing to that number 27 that's over here, right? Here it is. This is the number 27, right? And I'm saying that's 27. Let me go and change that 27. I can't do that, right? That 27 will stay 27 forever, for all of time, right? Because it's an immutable object. Ints are immutable. Versus a list, let's say this is a list, and this is a list which has the number 27 in it, right? A list with just one thing, 27. Because lists are mutable, and I'm referencing that list, I can say that list, I want to change it. I want to add a number to it. I want to add the number 13 to it. I can do that. I can go, I grab it, open it up, put the number 13 in it, close it back up, and now we have a list of 27 and 13, and it's still that same object, right? Okay? So that's lists are immutable. Sorry, lists are mutable. Whoa. Lists are mutable. Ints, floats, strings, immutable. That makes sense? Yeah? All right. Anyways, so when we are modifying a list, we did cover this last week, right? When we're modifying a list, we have our numbers, right? 11, 12, and 13. We have something called clear list. We're going to put our list inside. We go inside our function. For IDX in range of length of LST, this IDX number, what numbers are we going to be seeing with this? Yeah?
Oh, 0, 1, and 2.
0, 1, and 2. Why are we going to be seeing 0, 1, and 2?
Because the length of the list is 3 and it's getting the range.
Length of the list is 3, right? So this is going to be the number 3. When we look at the range of something, if we have just one number in it, that's just our stop, right? So we start at 0 and we go all the way up to that number, exclusive, so we never reach that number. So we start at 0, then we go to 1, 2, this length of list is 3, so we never reach that 3, right? So we get 0, 1, and 2, right? So IDX is going to be 0, 1, and 2. So then we go to the list, and we check to see its position, and we're going to make it equal to 0, right? Whatever it may be. But we're never like returning anything here. We're never printing anything in here, right? We're just grabbing the list and mutating it, right? Changing it up. Then, after we're done and changing everything to 0, we go over here and we print our nums. What will nums be?
I think all 0.
All 0? Let's check it out. Let's see if it's all zeros. Let's go Python tutor. Okay. We have this list called clear list. We know that it exists. We're not going to look at it until we go inside. Then we have nums. Nums is 11, 12, and 13, right? This is our reference going into this object, 11, 12, and 13. Then we're going to go into this function called clear list, and we're going to pass in our list of nums, right? Nums. And now we have a new reference, right? Called LST because that's what we gave it. That's the parameter name. LST. But LST is pointed to the same object. This one right here, right? It's pointing to the same exact thing. Previously when we had integers, right? With integers, it created a new thing, and it looked at, like, this was a number 10, and then this was a number 7. It looked at different things, right? Or two different number 10s. This was a number 10, and this was a number 10. Here, we're referencing the same exact list, right? So if I'm pointing at that chalk, and Tyler's pointing at that chalk, it's still the same piece of chalk, right? Own thing. So, then we go inside. IDX is in the range of the length of the list, right? And in this case, we start off at 0, because again, ranges start at 0. We go in, and we look at list at position 0 minus 1. What's 0 minus 1? Negative 1. What's the position of a list at negative 1?
It's in the end of
It's the end of the list. It's the last one because you're starting at the right and reading right to left instead when we're looking at negatives. Right? So then we had 0 and went to -1. Now IDX is 1. What's 1 minus 1? 0. So in the list at index 0, where is that?
11.
Yeah, it was 11. This is the very beginning, right? This is the beginning of the list, and we made that now into 0. Then IDX is 2. What's 2 minus 1?
1.
1. So what's list at position 1?
12 and now it's going to be 0.
Yeah, this was a 12. And now we're going to be setting it to 0. So now we changed it to be 0. We're done with our for loop because we finished up 0, 1, and 2. We're not returning anything. We're not printing anything. We finished clear list. And now we're going into print nums. So when we print it, nums, what's nums right now?
0, 0, 0.
0, 0, 0. All zeros. Well done. Does that make sense? How we can like update, mutate a list within a function? Yes? Any questions on that? Yes, no? 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 All right. Strings. Remember what we said about strings? What can strings do? Or what can they not do?
Change.
They can't change, right? It's unfortunate. Strings, you wish it would change, but they can't, right? Stuck in the raised strings. So that means we have our name called Annie, and we're going to put it into update first character, and we're passing in our name Annie, right? We go into Annie, so we put Annie into here, update first character, and we're trying to make name at position 0 be the capital A. Will this print out Annie with a capital A, Annie with a lowercase a, print out Annie with all caps, or will it throw an error at us? So we finished setting this name to 0 to capital A, we go over here, and now we print out name. What will happen?
You'll get an error
You'll get an error. Why is that?
because you can't like change the string of the brackets.
You cannot change a string with a bracket, right? You just cannot do it. Strings are immutable. They will stay the same, no matter what, right? Can you look at name at position 0? Like if I were to put print at name at position 0, can you do that?
Yeah.
You can do that, right? Because strings, you can look at the position, right? The position of our string, N. And you can say, what's the first letter? What's the name at position 0? You can go and look at it. You can look at it all you want. You can look at the position 0, 1, 2, 3, 4. You can look at it. But you cannot change it. As soon as you start to try and change it, name at position 0 is equal to something else. Wrong, error, can't do that anymore. Okay? Because why?
Strings are in.
Strings are immutable. Sound good? Want to run it just to look at it? Let's just look at it. Okay. Boom, we run that. Oops. String object does not support item assignment. Name at position 0. Cannot do that. Okay? All right. Let's continue on. So today, we're covering a little bit of things about functions, right? We've used functions a lot so far. I think we've used functions since like day 2 or 3, right? But now we're going to go into the nitty-gritty and find out exactly what's happening behind the scenes about how these functions are actually working, okay? So far, we've been seeing us look at functions, say we're not going to get to that until later. I know that it exists, but I'll get to it later, right? Then we grab stuff, put it inside the function, work with it. Sometimes we return stuff, sometimes we print stuff, sometimes we don't, right? But today we're going to be calling, or we're going to be looking at something called a call stack with a 1 stack frame and a call stack with 2 stack frame. It's a lot of big words right now. We'll go through it one by one. Also the scope of variables, right? Something what's called local and global variables. We'll also cover that really quickly. Not quickly. We'll cover that shortly. Shortly is the right word, right? And we'll get to this, and this is also related to call stacks, right? And then passing parameters to functions. So we've been passing stuff into functions all the time. right? We pass in numbers, we pass in lists, we pass in strings, so we could use later on. But we're also going to see when we pass stuff down there, how does that affect our program as a whole, right? This is all going to be like the back end stuff. What's happening inside the Python file? Okay, so we're going to start off with something called stack frames. Okay, so we have functions, right? Functions. Let's say we have a function called def is going to say greeting, right? We have a greeting. We have a function. And we can call it anytime we want. Let's just say print hello. Right? That's all this function is going to do. That's it. Anytime we call it, we're getting a new, something that we call a frame. Okay? A frame for holding variables. So now instead of saying just greeting, we say greeting x, right? Let me update this to be hello plus x. So what's going to happen here when I call greeting is my
Greeting and plus the name that you gave it.
the name that I gave it. So what's going to print out when I put x equal to Ismail?
Hello Ismail.
Hello Ismail. Okay, that's what it's going to give us, right? But this name x, right? This name now exists into something called a frame. All right, frame is basically just an area of any variables that we can use. All right, and we're going to look at it right now in the Python tutor. Right, so we can see actually visually exactly what I'm talking about. Okay. So parameters, right? Parameters are the things that we pass into our functions, like this letter x. This letter x is going to exist within this function. And then we have variable names used within a function. So basically, if we were to do this, y is equal to, let's say, Angel, right? This y variable exists within this thing called a frame. Okay? Let's look at what a frame looks like. Just in general. What is this frame that we're talking about? We've been seeing that a lot recently, actually. I'm going to edit this code right here. So we have our greeting. Greeting. We're going to pass in x. So we said we're going to print hello x, right? Just printing out the name that we're passing in. Then we're going to make y equal to Angel. And then we're going to have over here, maybe we're going to have my name is equal to Ella, right? Ella's name. Then we're going to put a greeting. And we're going to put my name. And let's just see what happens, right? So as we've seen before, greeting is a function. And we know that there's a function there. And we'll look at it when we get to it, right? But now, this greeting is into something called a global frame. Okay? We'll get into global frame right now. Okay? But this frame, global frame, is going to hold a bunch of stuff. Right now it's holding a function, right? Greeting. It exists, right? And we can look at and use greeting anytime we want because it exists inside this function, right? Inside this global frame. Then we go next. My name is a variable, and now my name is holding this string called Ella, right? My name is Ella, and this is existing inside this global frame, right? And again, we'll get to global frames right now. Now we're going to call greeting. When we call greeting, right? When we call greeting, we grab the name, my name, right? Whatever's my name. What's my name right now?
Ella.
Ella, right? Ella. We're going to grab it and we're going to go up to the greeting and we're going to start our function. Okay? When we start our function, as you can see, we have this thing called global frames. That's a little line that holds greeting and my name. But now greeting, this function, has its own little line, right? Its own line. This is its own frame. What that means is, whenever we're inside of this function called greeting, it has its own little thing called a frame, right? Think of a frame like something that you can look into, right? A frame. It just exists within that frame. Or a picture frame, right? You can look at only the things inside that frame. Right now, this frame only has one thing. and it's called x. And what is x right now?
Ella.
Ella. Why is x Ella right now?
Because you passed my name instead of Greek.
Yes, we passed my name, which was Ella. We grabbed it, and we put it into greeting, and we're saying, greeting, you're going to have a variable. It's going to be called x, we're calling it x, and x is right now Ella. Okay, does that make sense so far? Okay, so x exists, this variable exists within this function frame. This frame we're going to call it greeting. Okay, this greeting frame. And we call it greeting because that's the function name, right? Then, we're going to go in to the next line, and it says print hello x. What should this be printing?
Hello, Ella.
Hello Ella, let's see if it works. Ta-da! It worked. Up here we see hello Ella, okay? Why does it do that? What it's doing is, so before we print it, so I went back, right? I went back one, so we haven't printed Ella just yet. What we're doing here is, on line 2, we're going to say print hello, and then whatever x is, right? Whatever x is going to be. Greeting knows that x is equal to Ella, right? So greeting, the frame, is going to look around and see what variable names do I have? Do I have a variable name called x? I do. X is equal to Ella. And so when we read this line, print hello x, this greeting frame, because we're inside of this frame right now called greeting, we're in here, when we step into it, right? When we step into the function, we're stepping into the frame. Once we step inside, now the things that we can look at are things that we brought with us, right? We brought with us this x. What is x right now?
My name, which is Ella.
My name, which is Ella, right? So right now when we stepped into the function called greeting, we brought something with us, x, which is Ella. So when we try and print hello x, when we're inside the function, we know x right now is Ella. So we're going to say hello Ella. Great. And we run it. Sorry, we go to the next step. We print out hello Ella. Does that make sense so far? About why inside this frame, this greeting frame, we can say hello Ella? Because it knows that x is equal to Ella right now. Then, I have a new variable, right? I have this variable called y. Y is now equal to Angel, right? So now while we're inside this frame, y is equal to Angel, right? So what if we were to do this? This code, print hello y, and just for old time's sake, Tyler, right? Hello. Let's run this. We know that there's a function. We're grabbing my name and we're placing it into the greeting. So again, as we're going inside a greeting function, when we create a new function, we're creating this new frame, right? We're going to look at new things now. The things that we're going to be looking at inside are things that we brought with us. What did we bring with us?
EX.
X, right? And x is right. What? Oh, x is what right now?
Ella.
Ella, right? So when we go inside the function, we're starting our frame here, and we're bringing in Ella. So when we say print hello x, while we're inside the frame, we're going to look around. What is x right now?
Ella.
Ella. So we're going to say hello Ella. Now we're going to say, while we're inside this frame, right? We're inside the frame still, inside the function. Now I'm going to say y is equal to Angel. Right? I'm just stating it. Y is equal to Angel now. Then I say print, oops. Then I say print hello y. When I'm inside this frame, right? I'm inside greeting still. What is y? Angel. So when I'm looking around looking for the letter y, the variable y, I say print hello y. Y is Angel. Okay? Next thing I do is I have z. Z is now Tyler. So while I'm still inside of this frame, I say I want to print out hello, and then whatever Z is. What is Z right now? Tyler. So we print out the name Tyler. Hello, Tyler. We finish our function, and then we leave. We're not in that frame anymore. Okay? We're outside of that frame. It's gone. We don't have to think about it anymore. Right? And then we finish. So what would happen if I were to do this? Right? So right now I'm bringing in my name, Ella. I go inside the greeting. I use Ella to say hello, X. X is Ella. So I say hello, Ella. What if I were to do this? Print hello, Y.
It won't know.
It won't know. Okay? Why won't it know? Let's go into, whoops. Sorry. Okay. Well, it's giving me an error right away. Oh, geez, why is that? Oh, okay, so we can start from the beginning. Yeah. So we can start from the beginning. Sorry about that. It just gives us an error right away. It says, hey, something's wrong. But we want to step our way until we get into that error. Okay? But we will find an error. So we start off at the very beginning. We see that there's a function called greeting. Great. We know that. Then we have a variable name called Elisa. Oh, sorry. The variable name is called my name. And we're naming it Ella. We're going to go into the greeting frame, into the greeting function, right? What happens when we go inside of a function? What are we creating?
Like a frame.
A frame. When we go inside a function, we're creating a frame. Okay? So let's go inside that function and create our new frame. Our frame is called greeting, because that's what the function name is called. Then we have X. And we named it X because we said we're going to call it X. Right? And so now X is equal to Ella. Then we do the same thing as we did before. We print hello X. We say hello Ella. We say Y is now equal to Angel. We say print hello Y. Y is Angel, say hello Angel. We say Z is equal to Tyler. We say let's print out hello Z. What is Z? Tyler, so we say hello Tyler. We finish our function, right? We're going to finish our function here. And once we finish our function, when we step out of the function, we're going to remove the frame. We're not looking at that frame anymore. Okay? It's gone. So now, we did everything we had to do in the function. We stepped out the function, and we're going into this next line called print hello Y. Right? When we try to print out hello Y, it says Y is not defined. But Y is right there. I said Y was Angel.
It only knows within the function.
It
Outside
only-
the function, it doesn't know.
It only knows within its function right now. Okay? We created the variable Y inside of a function, which means it's inside of a frame. Right? This frame, what are we calling that frame? Greeting is the function name. So we're going to give that frame name the same thing as the function. So within the frame called greeting, we have an X, we have a Y, and a Z. But when we leave that frame, or when we leave that function, we're leaving that frame, and that frame doesn't exist anymore. Okay? It's gone. It's out of there. So when we say here, print hello Y, our system fails, and it says, whoa, I don't know what you're talking about. You're saying Y? I've never seen Y in my life. Right? We could do the same thing here with X, right? X. If we were to do that, we finish our function, right? Greeting, my name was Ella. Then we try to print out hello X. X does not exist in our thing called a global frame, right? We never made something called X. So when we try to read X, it's going to say, whoops, sorry, I've never seen X before in my life. I can't help you with that. And it's going to give you an error. Okay? Any questions so far about these like function frames? Like we step into a function, we bring stuff with us, right? Like this variable X, which ended up being Ella. We created stuff inside it. Y is Angel, Z is Tyler. We did stuff with it. We left the function. And once we have left the function, we have left the frame. So now X, Y, and Z don't exist outside. Does that make sense so far? Great. Awesome. So that leads us into this next thing called the global frame, right? So now we looked at these other frames, right? When we create a function, we create a new frame. We go inside that frame, we bring stuff with us, we create stuff inside it. All good, right? And then I said there was this other thing called the global frame, and I'll get to it. Now, we're here. We did it. We're going to talk about the global frame. Whenever we start a Python program, as soon as we start it, right when we're reading the very first line of code, there will always be one global frame that all functions can access. Okay? The global frame is the thing that exists immediately. Okay? Immediately. As soon as you start something. Let's look at this again. Let me just remove this. So it'll give me an error. Right? We're about to read line 1. Let's read line 1. As soon as I read line 1, a global frame is created. Okay? Global frame. Our global frame will always be the very first thing we create. Okay? And even though we're going into these other functions, right? So we have my name. We go into the function called greeting. Global frame still exists. Okay, global frame is still there, hanging out, right? Because we have not finished with the global frame yet. We're not done. We haven't finished the whole program. But after we do our printing, we leave the local for the frame called greeting that we created. We left it. And then we finish our whole system. Once I finish the whole code, and my code's done, then my global frame is done. Then I'm done with whatever global frame was. Okay? Because I'm done with the whole Python file. Does that make sense so far? So global frame, when is it created? Immediately, right away. As soon as you start reading the first line of Python file, it's created. Global frame, boom. Okay? Here. There's always one global frame that all functions can access. Okay? Oh, I'll actually get into that sentence right now. Oops. So, let's look at what we mean by that. Okay? So, this is kind of showing us what Python Tutor was already showing us, right? Where we have this global frame, right? Global frame holds this variable called circle area, right? Circle area. That circle area is going to hold something. It's going to hold whatever area of circle 10 is going to give us back, right? It's going to return from the function. When we call area of circle with 10, we create a new frame, right? The area of the circle, area of circle frame, because that's what this function name is called. And we have this variable called rad, right? Radius, rad, right? So rad is 10 because we passed in that 10 into there. Then it's also going to have this other variable called area. And area is going to be 314 point whatever for pi, right? It's going to return, then so we have it has this variable called area. Then it's going to return that and give it to circle area. Right? But this rad and area only exists inside here. Okay? Only exists inside there. Just like we talked about before. With frames. Does that make sense so far? Frames and all those things? Okay? So, let's look at this. The call stack with one stack frame. A stack frame, right? So, okay, so in Python, there's a thing called stacks, right? It's just like stacking cups. I have this cup, and then I have this cup. What Python does is, the very first cup it creates is global. That's my global frame. Then I can stack on top of that. I have this thing called area of circle. I'm stacking on top of that one, okay? That's why it's called stack. Just giving you the reason why it's called a stack. Right, we're stacking stuff on top of each other, like cups. And then when we're done, so we create an area of circle, we'll grab this frame, we put it up top, stack it on top. When we're done with area of circle, we return area, we take it off. Okay, we take it off the stack. We're not looking at it anymore. It's just like when we grab something, we do some stuff with it, and when we leave the function, we leave the frame, and that frame is gone to us now. We don't have to worry about it anymore. It's like us grabbing this frame, put it up top, do all the things we want, and once we're done with it, you throw it away, right? You throw it away, it's gone. But we still have this global frame. Okay, that's why they're called stacks. I just wanted to show that visually of why they're called stacks. Okay, so let's grab this, put it in here. So just like before, as soon as we start reading something, we start our global frame, and we imported math. What's importing again? What are we doing?
You're just getting something that someone else created and bringing it into your idea.
Yeah, exactly. You're getting some, like, it could be hundreds of thousands of lines of code. You don't have to know what they are, but you know that they exist and you're importing it in. We're calling it math, right? And we're saying math has a bunch of stuff, and I want to access whatever math has, right? So but as soon as we did it, as soon as we started, there's this global frame, right? Then we read that there's a function, right, called area of circle. We haven't read the function inside yet. We just say we know that there exists a function called area of circle. Then we're going to make circle area equal to whatever area of circle is. Okay? So we're going to go inside of the area of circle, right? And we create our new frame, area of circle. And we're bringing into area of circle a number. What is that number? 10. This 10 that we have here. What are we calling that number 10? What is the reference to that number 10 when we're inside of area of circle? Rad. R-A-D, rad, radius. Right? So, rad exists inside of the function, right? Area of circle. So we can say rad 10. Then we created something called area, because we calculate the area. Area is equal to math.pi, which is 3.1415926, times radius, because that's just how we calculate the area of a circle, right? Then once we finish calculating the area of a circle, we hold that number here in a variable inside of area of circle frame, inside this frame. That's what we're calling it. Then we're going to return, we're going to grab that data, and we're going to give it back to the user with a return. I'm going to say, hey, I have this number called 314.1593. Python says, great. Give that to me. We leave that function, but we bring with us whatever we return, the area, and we're saving that into circle area. So circle area is now whatever we brought back with us, right? That return. And then we can just print it out. 314.1592653. Does that make sense so far? About like this frame, we had this frame. So we start off with a global frame. As soon as we go into a function, we create a new frame, right? And we're calling that frame area of circle frame. Inside of area of circle, we can use rad, we can use area, all these things so far, just like we had before. Does this make sense so far? Yes, no, yes, no? Any questions on this? No? No? Okay. Cool. So what's going to happen when we run this?
Well, there's no parameters for the
There's no parameters inside here. Can you call a function without a parameter?
yeah.
Yeah, so it shouldn't be an issue so far, right? So we have a function called set x. Inside the function, we say x is equal to 100. And then outside of that function, we say print x. What's going to happen?
It won't know what x is because it's outside the function.
It won't know what x is because it's outside of that function, aka outside of that frame, right? And as soon as we're done with that frame, it's gone, right? So, let's see. Yeah, actually, yeah, so we have some slides for that. So, functions do not execute unless they're called. So the very first thing that we're going to see is that we never called set x anyways, right? So x was never looked at even once, not even inside the local frame. right? Inside the frame called set x. Inside the frame called set x, we never created x because we never called the function. So first thing we have to do is call the function. So let's call the function, right? We call the function set x. Now we go inside here, set x, x is equal to 100, and we're trying to print out x. What's going to happen now?
Still nothing.
Still nothing. The variables created in the function die, well, they are gone. Let's say that they're gone. Variables created in a function are gone after the function returns, okay? After the function returns or after the function is done. So it doesn't have to return anything, right? Even if we're just printing stuff inside, when we leave, it doesn't have to return. So I'll update this right now. So variables created in a function are gone after function finishes, right? So the function could also just like not have any return statement. But as soon as we leave that function frame, that variable x, even though it existed inside the frame, set x, we cannot talk about x anymore out here because x does not exist in the global frame. We never see it, right? We never see it at all. So we can also do this. What will happen when we run this code? Okay? So now we're not printing anything outside. Right? We're not printing anything outside here. But now we're just going to call count 3 times. What's going to get printed when we run this code?
2, 3, and
2, 3, and 4. Let's try that out. Okay. Grab this, put it into Python Tutor. Okay. That's, oops, oh, that's me, my bad. I didn't put these indents, okay? So this is the same as this over here. Yes, let's run that. So now, as soon as we start, we have a global frame. Global frame says, there's this function called count. I don't know what's inside it, but I know that it exists. And we'll get to it when we get to it. And we immediately get to it. Count. Awesome. Let's go inside count. Right? When we go inside count, we create a new frame. Right? Called count. What's inside that frame so far? Nothing. Right? We didn't bring anything with us. Right? We didn't bring anything with us. So we don't have anything inside the frame yet. Then we say x is equal to 1. So now, inside the frame we have this thing called x. Then we update it. X is now equal to 2. And then we print whatever x is. Now it's 2. Okay? Great. Now we leave that function. We did everything we had to do. We printed what we had to do. We finished the function. We left the function. When we leave the function, that function frame called count, the count frame in this case, is gone. Right? We crumpled it up just like those bottles. As soon as we finished what we had to do, we threw it away. Now we call count again. All right. We're restarting. We're restarting everything. So now we go into count. Does the count frame have anything in it yet?
no.
No. We didn't bring anything with us, right? We didn't bring anything with us.
Oh.
So now x is equal to 1. I think I just heard a light bulb moment over there.
Yeah.
That's great. So x is equal to 1. So when we're in the frame, we say x is now 1. And x is 1 inside the frame. Cool. Then we update it to be 2. X plus equals 1, that is the same as saying x is equal to x plus 1. X is 2. Then we print out whatever x is. X inside this local frame, this count frame, is 2. So we print it out 2. So we print it out 2 again. So what's going to happen when we get to the third time we call count?
Another 2 is going to be.
Another 2 is going to happen because we leave the frame, we go back into the frame, we restart the frame, x is equal to 1, x plus equals 1, so that x equals 2. Then we print out x, whatever x is, which is 2. We print it out, we leave, and we're done. Okay. 2, 2, 2. Does that make sense? Right? We entered a frame, we did what we had to do, we left the frame. We entered the frame, everything restarted, we do what we had to do, we exit the frame. Enter the frame, like that, over and over and over again. Does that make sense? Yeah. Awesome. Great. So, variables start fresh every time a function is called. Every single time. Okay? Anytime you called count, we made x equal to 1 again. Okay? It all restarted. It doesn't remember what it had before. Because when we finished the frame, what did we do when we finished the frame?
Stepped out.
You stepped out, and what do you do with that?
It's not.
It's gone. You throw it away. Cut it a second. You throw it away. It's gone. You forget anything that happened before. Okay? So now. So that's the call stack with one thing stacked on top, right? You got one thing, you stack it on top of another, and we're done. Does that make sense so far? Now what we can do is while we're inside of this frame, we can call another function, which means we're going to grab another thing and stack it on top of that. Okay? It's going to be called, instead of a one stack frame, this is called a two stack frame. Because we have our global frame at the bottom, then the first function that we called, and then while we're inside this function, we're going to call another function. That's going to be our second frame. Let's look at what that looks like here. Okay? Whew. All right. So, let me show y'all what that looks like here. Okay. So, using math, let's just think about our math stuff, our geometry actually, with geometry. So, in geometry, we know that to get the area of a circle, we have a circle, right? To get this area, we have to look at the radius, r, right? And we're basically getting all of this area. We're calculating this. But we also know, with geometry, if you get the area of a circle, but you make it into, what is this? A cylinder, right? In order to get the volume of a cylinder, basically how much does this cylinder hold? You get the area of the circle, this area of the circle, right? And you have to multiply that by its height, right? Whatever that number may be. So you can get the area, or like, sorry, the volume of the entire cylinder. Okay? What that means is, in order to find this, you first have to find this. And what we can do is, we can have a function, so a function called area of circle, right? And it's going to calculate this, right? It's going to find out whatever the area of that circle is. But what we can do is, we can have a function called volume, I can't spell, volume of cylinder, let's hope I spelled that right. And the volume of the cylinder can calculate this, but what it can do is, before it calculates all that, it's going to calculate this first, bring it into here, so we can calculate the rest. Okay? Let's look at that in action here. Okay? So now, we have our code, right? This is all the same stuff that we had before. What's the first thing that's going to happen here? We don't have any frames or objects yet. We haven't read a single line of code. We're going to read our very first line of code, which is import math. What's the first thing that happens?
Yeah, global frame.
Global frame. Very first thing that happens immediately. Okay, you have this thing called the global frame. Great. Our first thing, our first bottle, right? And we're importing math. Math is a bunch of code that we want to use so we can use it for later. We read our line 3. We know that there's a function and it's called area of a circle, right? Area of circle. We haven't read it inside yet. We're not looking inside yet, but we know it exists. Then we look at line 7. volume of a cylinder. We know that it exists, but we're not going to go inside yet. Okay, not at all. Then in our global frame, we're also going to create something called radius. What is radius equal to? 10. And we're also creating something called height. What is height equal to? 2. Okay. And what we're going to do is, instead of calling area of circle first, then grabbing area of circle to put that into another function frame called volume of circle, of a cylinder, what we're going to do is we're going to immediately just call volume of cylinder. Okay? And we're going to pass in the radius and the height. Right? The radius and the height. Are people with me so far? Yeah? So, we're going to go into the function called volume of cylinder. What happens when we step into a function?
Then go, there's a new frame.
There's a new frame. We create a new frame. What are we going to call that frame? Volume of cylinder, because it's just the name of the function that we're going into. Okay? An easy way to remember it, right? So we step in. Are we bringing anything with us?
Yeah.
Yes. What are the things that we're bringing in with us?
Radius and height.
Radius and height, right? So when we go inside, we're bringing in the radius and we're bringing in the height, right? These two things are coming with us as we go inside this frame. Great. Everyone with me so far? Great. So now, what we're going to do is we're going to say volume is equal to the area of a circle with a radius times the height. So just like over here, we get the radius of a circle to get the area of the circle. Then we're going to multiply that by the height to get the full volume of the whole cylinder. Does that make sense so far? Well, just like geometry-wise? Yeah? So that's how we're supposed to calculate the volume. But when we're saying volume is equal to the area of circle radius times height, what is area of circle? What is area of circle? What is that?
Another function.
It's another function, right? So that means we're going to go into that other function, right? Area of circle. Are we bringing anything with us? Yes. What are we bringing with us?
Radius.
Radius, right? We're bringing in the radius. What is radius inside of this frame? Volume of circle, of cylinder? 10. We're going to pass that into the area of circle, radius. We go into area of circle. We bring in the number 10. Inside of the area of circle, what are we calling that? The thing we're bringing with us. Is it called radius?
Rad.
No, it's called rad, right? It's called rad. So rad is equal to 10. And as you can see, we have our global frame. We still have the volume of circle of the cylinder. We have not finished with it, right? We have not finished with it. But instead of stepping out of it, we're stepping into another function. We're going deeper into the hole, right? We step into another function called area of circle. So now we created a new frame. There's a new frame called area of circle. And we're bringing in the number 10. We create the variable called area. Area is equal to math.pi times radius times radius. So area is equal to 314.1593. Everyone following so far? We're going to return whatever area is. What is area inside this frame of area of circle? What is area? 314.1593, right? Is whatever this is, area. So we return it. We're going to say we're going to grab this stuff. We're going to take this with us. Everything else is going to disappear. So we go back. Right? We finished with our function, area of circle. Area of circle with the radius that we gave it a 10, and there being 314.15. And we're going to use that and multiply that by the height. Right? So now we multiply that with the height of 2. So now we have volume is 628.3185. Is everyone with me so far? Right? So we started the global frame. We stepped into the volume of the cylinder. While we're in the volume of the cylinder, we stepped into area of circle. Right? Now we're inside the area of circle. We did all the stuff we wanted to do. We're going to return some stuff and give it back to the user. We're going to step out of the area of the circle. And we're still inside the volume of cylinder. Okay, we're still inside here. So radius still exists. Height still exists. Volume, which we just created, still exists. Now we're going to read the next line. What's that next line?
Return volume.
Return volume. What does that mean we're going to do?
We're gonna take it with us.
We're going to take something with us, whatever volume is. What is volume right now?
628.
628.3185. I'm going to grab that, and we're going to step out of the function. What happens when we step out of the function?
It erases everything.
Erases everything inside the frame of that frame called volume of cylinder. It takes it all out. Right, so we have this return value, right? We're going to keep this piece of data and we're going to give it back. So now volume of cylinder that we have here, which is equal to whatever the function returned. The function returned this number, 628.3185. But now, that volume that was in here, that's gone. That volume that's in there does not exist anymore. Because we destroyed it, right? It's done. It's forgotten. After we finished with that frame. We stepped out of the frame, we forgot everything in there, but we kept one piece of data, and it's the thing that we returned. Right? Does that make sense? Yeah? Then we print it out, and we print it out. 628.318530.717.9587. Okay? Does that make sense? How this two-call stack thing works now. Right? So we started off with our global function, right? Our global function. Our global frame. It's right there. Then what did we call? We called another thing. What's the thing that we called? What's the function that we called? What is this new frame called?
Oh, volume of cylinder.
Volume of cylinder. Because we called it right here. Volume of cylinder. We're stacking that on top of this. While we're inside the volume of cylinder, we call another function. What's that function called?
Area of circle.
Which means the frame is called?
Area of circle.
Area of circle. Put that on top of this. It did what it had to do. It finished, and it returned some information. Now anything inside of area of circle is gone, and we brought back something that we returned from it. We finished whatever we were doing here in the volume of cylinder. We finished the volume of cylinder. Anything inside it is gone. We return whatever it wanted to return to the global frame. We're inside the global frame, volume cylinder. Volume cylinder is equal to whatever volume of cylinder returned, which is 628.3185, and then we can use that for later on. Print volume of cylinder. Does that make sense? Yes, no, yes, no? Any questions so far? No? All right, so this is just also visualizing the same stuff. We started with our global frame. We're stacking a cup on top, right? We're stacking this frame on top first, which is volume of cylinder. While we're inside the volume of cylinder, we stack another thing on top of that, area of circle, right? The number 3. And then once we finish with area of circle, we remove that. When we finish with volume of cylinder, we remove that. We finish our stuff. As soon as we're done with the whole Python program, we remove the global frame because we're done with the whole Python file. Okay? So that's what the call stack with 2 frames is. All right, so we just went through that. So what's going to happen here? We have this function called display x. Okay. So we're going to print out x. We have this function called main. And we have x is equal to 100. Then we're calling display x. And then in our global frame, we have main. We're going to call main, the main function. What's going to happen when we run this code?
It won't print anything.
It won't print anything. Will the whole thing run or will it get an error?
I think it will run, but it won't.
It'll run, but nothing will print? Let's try that out. Oops. Well, yeah, it says name error. We actually get an error. Okay? We get an error. Why is that? So we read the very first thing. We create a frame called global frame. And we say there exists a display x function. Cool. Then we say there exists something called main function. Cool. We're going to step inside the main function. And what is that going to do as soon as we step into a function?
It'll create a new stack.
It'll create a new stack. So yeah, this stack, what's this called? This is called a frame. Remember? Yeah, it'll create a frame and put it on this stack, right? It grabs it and stacks on top. We got something called main. Cool. Inside of main, we created something called x is equal to 100. Okay, x. So inside of the main frame, right? The main frame happens in the main frame. Inside this frame called main, we have x is equal to 100. With us so far? We step into display x, right? So display x is being created. What is this again?
Frame.
A frame. And we created this frame because we're stepping into this function called display x. We step in, and we're going to say we're going to print out x. While we're inside display x, what is x equal to?
There's no x.
There's no such thing. There's no such thing as x, right? Because when we go inside of x, when we go inside display x, are we bringing anything with us? No. Are we creating something inside it? No. So therefore, while we're inside display x, there's no variables that we can work with yet. Nothing at all. Okay? Therefore, we get this error. Name x is not defined. X does not exist while we're inside there. Okay? Does that make sense? Right? Only things that are created and or either only things that you bring with you or things that you create inside of a function will exist for that function frame. Does that make sense? Yes, question.
But if, like, let's say you put return x in between x equals 100 and display.
A return here?
Yeah.
Okay.
It will actually print out x.
Let's try it out. Let's try it out. So we have this. So you're saying something like that. Return, and what do we put here? X?
X.
X? Let's return x. Okay, let's see what happens. So we start off with our function, display x, right? We know it exists, we're not going to go inside it yet. We know that there's this function called main. We know it exists, but we're not going to go inside it yet. Then we're going to call main. We're going to go inside main now. Okay, let's go inside main. Are we bringing anything with us into main?
No.
No. So we have nothing inside the frame yet. Then we say x is equal to 100. We created something inside the frame. What's that thing called? What's that variable called that we just created?
X.
X. And what are we setting x to? 100, an integer. Then we say return x. However, remember, what happens when we call return in the function? That's one way of thinking of it, right? It'll break. What happens is when you call return, it doesn't matter what's happening inside the function, right? It doesn't matter if you're in a for loop. It doesn't matter if you're in a conditional. It doesn't matter what's going on. No matter what, as soon as you say return x, you get out of there, and you ignore anything else, okay, inside that function. So when we return x, we actually are returning, and we never really read display x. We never read it. Okay? We never read it, and we leave the main function. Right? So now we have no frame called main. We go back to the global frame. We returned x, which is 100, but we're not saving it anywhere. So yes, main gave us the number 100. We didn't do anything with it, which is fine. And then we finished our code. No errors happened. Right? But we never displayed x. But do we understand why we never went into display x? Because we returned. And what happens when you return?
It won't read anything that's below.
It won't read anything else. It grabs whatever it was reading, whatever you want to return, and you immediately leave. Immediately. Okay? Great question though. Okay? So that's what would happen. We'll run that code. You can't see the variables of other functions even those that call you, right? So display X was called within main function, right? So you have your global frame, you have your frame called main, you have your frame called display X. But since you never passed anything into here, you never passed any variables inside display X. Display X, what does it know right now? Nothing at all, right? It doesn't have anything in this frame. Therefore, when you try to print X, X does not exist within display X. So therefore, you get an error. Does that make sense? Yeah? Now, we have these things called local variables, and we have these things called global variables. Okay? This is very important. So we have this thing called the global frame, right? Global frame is the first thing that happens. The very first thing that happens in a Python file. A global frame. Within the global frame, if you create a variable inside that global frame, that variable is called the global variable. Okay? Because it's created within the global frame. Global frame is going to be the most special one of them all. Right? It's the first thing that happens when you start a program, and it's the last thing that leaves when you finish a program. Okay? Global frame is very important. So when you create a variable inside of the global frame, that's called a global variable. Right? That's what it's called, a global variable. Then there's these other things called local variables. Local variables are basically all the variables that exist within a frame that do not exist in the global frame. Okay? So let's look back at some of these examples that we had. Okay? Geez. Is this gonna? Nope, it's not gonna let me do anything there. Let's make this new thing. Let's have, actually, do we have, is it the very next slide? Because if it is, it's gonna be real nice. Yeah, let's do this one. Okay. Let's look at the difference between local and global variables. Okay. So, what do I mean when I say local and global variables? A local variable only exists within a frame, but a global variable, which is created in the global frame, is called a global variable. So, as soon as we read the very first line, we create our global frame, and we created a variable called message is equal to hello, right? Message is equal to hello. We know that. We read the next line. Greeting, right? Greeting is a function. We know that it exists. We're not calling it yet. We're not going to know what's inside of it yet. But we just know that it exists. With this piece of code, what we know about frames, what should be happening here?
It should erase and not remember.
It should erase and not remember things. So the things that get erased is when you leave a frame, right? Right? Is what happens when you leave a frame. So we have this variable called message, right? We haven't entered any other frames, just the global frame. And we're calling it hello, right? Then we have this greeting, and we're going to print out a message. Then but we haven't read it yet. We're going to print before we do anything. We're going to print out message. What is message right now?
Hello.
Excuse me, it's hello. Then we call greeting. We go into greeting. Do we bring anything with us in greeting? Then we say print message. Does message exist inside the local frame? No? Right? From what we've learned so far, that's exactly what should happen, right? Exactly what should happen is, when we go inside this frame called greeting, message doesn't exist within greeting. So shouldn't we be getting an error? Let's look at what happens. So before, our message is hello, right? We just print out the string before, colon, a space, plus whatever message is. Message in this case is hello. We know that so far. Then we go inside greeting. Then, inside greeting, do we bring anything with us? No. Do we create anything inside? No. But inside this frame called greeting, we're going to try and print out message. And we actually do print it out. Hello. This is why global frames and global variables are very special. Okay? Because a global variable, global, aka the whole entire world, right? A global variable can exist within a frame, within a local frame. So even though greeting, we didn't create anything called message inside greeting, we didn't bring with us anything called message into greeting, but greeting knows message. Because message is a global variable. Okay? Global variables exist in the global frame, and if they exist in the global frame, they can exist in other local variables. Sorry, in other local frames. Right? So we were in the greeting frame. We didn't bring a message, we didn't create something called message, but we said print out message. Right? And it could understand it still. Because the global variable of message created on the global frame can exist within a local frame. This is a kind of tricky concept to understand right off the bat, but is anyone confused so far? No? Yes, no, yes, no? I'll give you all a second. Yes?
Will it give an error if, like, let's say, for example, greeting has a parameter, and,
Okay.
and like, it has the same variable as message?
Okay, so greeting has a parameter. It has the same variable called as message.
Yeah.
So we call it MSG like that?
Yeah.
Okay, let's try that out. Let's run this code. Oh, we get a quick error first. So we read message is equal to